Hi everyone, I'm Dr. Poe, and in this video, which is hopefully going to be super short, we're talking about the agents, oxidizing agents and reducing agents in these redox problems. So when we're thinking about redox, we know, because we're super smart, that this is both reduction and oxidation. These have to happen at the same time. That's why we call it redox. Is because they both happen. If one happens, the other has to happen. And it's basically passing an electron back and forth. So the loss of electrons is oxidation. So oxidation is going to give up an electron, which we show here with its little negative charge. And it's going to be picked up by whatever is reduced. Right? And so for these agents, so like the redox is probably straightforward. The agents are a little bit weird, right? Because they feel like they're being named backwards. And that's because they're named for what they do. So let's talk about what the agents do. So an oxidizing agent is going to cause oxidation. Similarly, a reducing agent is going to cause reduction. So this is kind of similar to my kids. My kids are chaos agents. They are agents of chaos. They cause chaos everywhere they go. They themselves remain calm, and it's a little bit crazy. But you know, that's what it is. So oxidizing agents, that's going to cause oxidation. And here's something to remember. Oxidation is bad. Oxidation causes wrinkles. It makes, if you leave stuff out on the counter, oxidation's going to happen, and it's going to turn stuff brown, like my beautiful apples and my expensive avocados. It's turning brown. We leave our gasoline in our lawnmowers over the winter, and it gets rotten and it gets spoiled, and it's all because of oxidation. So there must be a lot of oxidizing agents around in the air that's causing this oxidation. So things that cause oxidation are going to have, and you know, if you're thinking about that, like what's in the air that could possibly cause oxidation, if your gut's telling you like, oh, probably oxygen, your intuition is exactly in the right spot. So a lot of oxidizing agents, a really common one, is going to be things with lots of oxygen in them. Oxygen causes oxidation. So like oxygen itself is a really great oxidizing agent, or things with oxidation with lots of oxygen in them, like hydrogen peroxide, that's a fantastic oxidizing agent, or chlorine bleach that has a lot of oxygens in it, that's a fantastic oxidizing agent. And so this oxidation causes a lot of damage. And so like on our bodies, we see this as like liver spots and wrinkles, but we can also use oxidizing agents to like brighten our whites and destroy bacteria and do all of these helpful things, destroy things that we want destroyed. Okay, so we can like eliminate dirt and that kind of things, okay? So oxidizing agents can be bad, but we can also harness their power. Reducing agents, because those cause reduction, reduction is good. Remember, these are opposites. And I'm going to guarantee at some point in your life, you've heard of something called an antioxidant. So an antioxidant combats the bad oxidation. So what are those antioxidants? Those antioxidants are reducing agents, and we see those things in like coffee and dark berries and dark chocolate and things like that. But really, chemically, what they have in them is lots of hydrogen in their formulas. So things like sodium borohydride in the lab and things like that, or even just like hydrogen gas, sometimes it shows up in equations. That's a really good reducing agent, and so that's going to combat the bad oxidation. It's going to cause good reduction. So I thought that this was kind of like interesting, that you're kind of thinking about this, like, oh, how can I apply this to my life? And hopefully this makes just a little bit more sense. Those agents are named for what they do. Oxidizing agents cause oxidation. Oxidation is bad. We don't really want that. They have lots of oxygens in their formula. Reducing agents cause reduction. Reduction is good. Those are our antioxidants. They tend to have lots of H's in their formula. But as always, make sure you're going back and looking at the exact products and reactants that you're given, and whatever is oxidized is the reducing agent, because it's taking that hit for you. These become oxidized. So it's like protecting you. It's like taking that oxidation bullet for you. And similarly, oxidizing agents, these get reduced. They take away the good, because they're the ones getting reduced. We want to be reduced. Okay, so keep that in mind, and I hope this makes a little bit more sense. Happy studying.